for physics. Yes, so today we are doing properties of one of the types of radiations. So in our previous lesson, we learned that there are three types of radiations that exist, of course, that are emitted or released or given out by radioactive materials. So now, today we are going to look at the properties of one among the three types of radiations that can be possibly emitted by a radioactive material or a substance that is able to release energy, which we call radiation. So the one that we are looking at today is properties of alpha particle. So an alpha particle is simply a particle that is usually emitted by a radioactive material when it has its unstable nucleus disintegrating. So now, the properties, among the properties of an alpha particle, we have the first one which says alpha particles are nucleus of helium with atomic number 2 and mass number which is 4. What does this mean? When you have a particle which is alpha in nature, it means it is usually compared to the nature of helium particle, because helium particle has, or the nucleus of helium, or the atom of helium has the mass number which is 4 and its proton number is simply 2. So comparing the two, we simply have alpha here, which is being indicated or symbolized by a symbol alpha there, and we have the mass number which is 4, the proton number for alpha is 2. So if we look at these two different particles, we are going to discover that even helium here, which is He, has the mass number which is 4, which is also equivalent to the mass number of alpha particle. Looking at also the proton number, you are going to discover that they both have similar proton numbers. That's the reason why an alpha particle is compared to helium atom in nature, because these two, they have similar properties in terms of their mass numbers as well as their proton numbers. The other properties of an alpha particle is that it is, apart from being helium in nature, they also travel in a straight line that is in a free space. So if at all you have a beam of particles which are alpha in nature, they are expected to travel in a straight line that is in a free space. So that means that space shouldn't have particles that should be able to disrupt the movement of these particles. And henceforth, at the end of the day, you are going to have these particles of alpha, or alpha particles traveling in a straight line that is in a free space. The other property is that they also ionize the gas they travel through. And the other property is that the range of this alpha particle in the air. So if you have particles of alpha that are emitted by a radioactive material, they are expected to cover a distance of about 5 to 7 centimeters. That is their range in the air. So this is an indication that alpha particles are unable to cover a longer distance in the air because of them losing their kinetic energy as they ionize the air they travel through. So now, in the process of ionizing air, they end up losing their kinetic energy. So as they lose their kinetic energy, you're going to discover that these will only cover a distance of about 5 to 7 centimeters in the air. So that is their range of the distance, maximum distance they are expected to cover in the air. So, apart from this one here, we move on to the other property, which is deflection. The alpha particles are deflected by both magnetic and electric field. What does this mean? So the reason why they are usually deflected by either a magnetic field or an electric field is because alpha particles have an electric charge, which of course is a positive charge. So if they are positively charged, they are also expected to be attracted or either to be deflected by a magnetic field or an electric field. So henceforth, you don't expect a magnetic field or an electric field to pose no effect on the alpha particle because they are charged, and henceforth they can be deflected by these two fields, which of course we are looking at the magnetic field and the electric field. So the other property is that they can be stopped by a thickness of a paper. Of course, that is just a very small diameter which will be able to stop the penetration of the alpha particles, which of course tell us to say that the alpha particles, or when they are emitted by a radioactive material or released by the radioactive material, they are expected to be stopped by a thickness of a paper. Which one are we talking about? Of course, this could be enough to stop the penetration of an alpha particle because its penetration power is not that strong to penetrate or to go through the thickness of this paper here. So these are the properties of the alpha particles. So an alpha particle has these properties here. So if you have an experience or if you observe that there is a radioactive material which is being emitted, which of course shows signs of only covering a distance of about 5 to 7 centimeters in the air, it can also be stopped by a thickness of a paper, and it can also be deflected by either magnetic or an electric field. It means that particle is a radioactive particle